Hello and welcome to my semester presentation, Algor Mortis and Livor Mortis, Physical Changes, for Thanatochemistry MRTS 1225. And the first slide I decided to kind of do a side-by-side, the differences between the two, what they are. Algor Mortis is the cooling of the body after death, the drop in temperature, and I chose this thermometer because it said 98.4, which we will use that number later. Livor Mortis is the pooling of blood after blood flow stops in the body. It's the pulling to dependent parts. And I use this picture because it shows the pressure of the slats on this chair where the decedent was laying was pushing, so the lividity spots or the livor mortis didn't take hold where that those slats in the chair were. But you can see in between where the lividity had dropped and had set in. And Algor Mortis is the second stage of decomposition. It starts fairly quickly after death, usually within between 30 minutes to an hour. And knowing the temperature can help determine the time of death for an individual. And body temperature is said to drop 1.5 degrees Fahrenheit for each hour. And this little chart I found shows how, as time progresses, temperature drops after death. The Glacier equation is a method of using body temperature to determine the time of death for an individual. It is said to be the most accurate way to determine time of death for medical examiners, forensic scientists, police officers, anybody really who needs to know that information can use that by using the Glacier equation. And that equation takes the 98.4 that we talked about earlier, and they use this because it's more common. Most people are closer to this number than they are the 98.9 that I'd always heard of. And you take that 98.4, subtract it by the internal temperature of the deceased, divide that by 1.5, and that would equal the hours elapsed since death. And that 1.5, again, is the degree dropped for each hour after death. A couple of things to consider when using the Glacier equation is clothing. If the deceased was wrapped in big blankets or had tight, restrictive clothing on, that could affect the rate at which the body drops its temperature. The size of the individual as well can cause the same thing. And the temperature of the surroundings is a big thing to look out for. Like, for example, if a deceased had died suddenly outside in the summertime, it's not likely, especially around here, that temperature is going to get much lower than 98 degrees. And so being outside in those elements, you also have to worry about other things such as animals. But for the time being, just talking about temperature, it's very hard for the body to cool down in its natural way after death when it's 100 degrees outside and isn't getting much cooler. So that's going to affect how they determine the time of death for that particular individual. Airflow is also something that will affect it in a great way. And to talk about livor mortis a little bit, it is the first stage of decomposition. It's discoloration of the body, the dropping of blood. It starts after the cessation of blood circulation. And our textbook, I think, put it very, very well, and a very better way to understand it is the gravitational pulling of blood to dependent parts of the body. And livor mortis, or hypostasis, or lividity, starts 4 to 6 hours after death. The red coloring found on an individual during the first stages of livor mortis is caused by the oxygen dissociating from the hemoglobin in the body. Over time, that turns to a purple coloring because of a lack of oxygen altogether. And I had always seen this, and I knew after a little while it would turn purple within my job, but I never knew why. And I think that is something very important to know, and I'm glad that I chose this topic and I learned that. Now, lividity is said to be at its maximum 8 to 12 hours after death. And blanching and hypostasis is, Webster's dictionary defines blanching as to make white or pale by extracting color. Now, keeping that in mind, blanching and hypostasis, our textbook talks about the digital pressure test, and what that would be is with a gloved finger, pushing on the discoloration spot on an individual, and if where you pressed with your finger, you see white, and you see the color dissipating from the surface, that is a telltale sign of livor mortis, that you can get that out with embalming and proper technique. And this is something very important to know as an embalmer. Now, this is a fun little illustration that I found, and it kind of shows the difference between all three stages. Even though we are just talking about livor and algor mortis right now, rigor mortis, he's saying I can't move. Livor mortis is my BP is low, and it's showing the pooling of the blood completely down to the bottom, to the gravitational pulling to the dependent parts, which is standing up, so it will go straight down. Algor is a thermometer saying burr because it's getting colder. And why do embalmers need to know this information? Well, for algor mortis, knowing how to find a time of death can be very helpful in an emergency situation. It's a good thing to know all around, because you need to know how long the body had been there. You need to know when the body was discovered, how much time could have passed. Even though this is more something that a medical examiner may need to know, I feel funeral directors need to know it as well. And it can help with embalming, knowing the time that has passed. It helps you refigure what chemicals you need to use, how much dye you need to use, different things like that. Livor mortis is important for embalmers to know, because viewing is very important to a family. And as a good embalmer, you need to know how to get those lividity spots out of the individual, especially if they're in viewing areas, and you want to do your best to have a good viewing experience for a family, because that's their way to say goodbye, to accept the death, multiple things. And here are my references. I hope you enjoyed my presentation over livor mortis and algor mortis. Thank you very much.